Assalamualaikum warahmatullahi wabarakatuh and hello everyone. In this video, we're going to discuss the week 2 hour 3 tutorial for both NFTF and also FTF questions. So at the end of this lesson, you should be able to determine the rate constants, activation's energy using Arrhenius equations by calculations. Alright, so from the questions, it states that the rate constants of a reactions is 3.46 10 to the power of -2 per second at 298 Kelvin. So the first sentence tells you about the first informations at temperature of 298 Kelvin. So let's say that this is your T1 and together with it is the K1. The rate constant is K. So now the questions ask you to calculate another rate constant. So it means this is K2. And at temperature of 350 Kelvin means this is your temperature 2. So let's recall again, whenever you are given two rate constants at two different temperatures, means you just need to use calculations method. Given the activation energy for these reactions is 50.2 kilojoule per mole. So now we're going to use the formula that involve the rate constants at two temperature, which is ln K2 over K1 is equal to negative EA over R 1 over T2 minus 1 over T1. So make sure your temperature is already in Kelvin. So now we're going to substitute the value. We have all the values apart from K2. So we want to find this K2. First, you need to substitute all the informations given in the questions. So we have ln. So we have K1 of 3.46 10 to the power of -2. Then we have K2 as unknown here. Equal to, so our EA is in kilojoule per mole. So you need to change the prefix of K to become 10 power of 3. So if we change this value, you're going to have 200, okay, and then our R is gas constant of 8.314 J per mole per K. That's why we have to change it to joule first instead of kilojoule. Then we have 1 over, so our T2 is 350 Kelvin. So you must check here that you use the correct temperature, because sometimes you often mistaken with the T1. Okay, right. So once we substitute all the value, you first calculate this value and then you shift-ln the answers on the right. Then only you can times it with K1. So lastly, your final answer of K2 gonna be 0.702. So what about the units? Let's check. Since our K1 has the unit of per seconds, means our K2 also gonna have per second as the unit. Okay. So moving on to the next questions, B. The rate constants of a reactions at 46K Kelvin, this is the T1, is 2.52 10 to the power of -5 per second. So this is going to be our K1. And at 503 Kelvin, the T2, the rate constant is 6.30 10 to the power of -4 per second. So this is our K2. Right? So now, the questions ask you to determine the activation's energy for the reaction. So the activation's energy gonna be the EA. Since we are given K1, K2, T1 and T2 value, then we can simply use exactly the same formula up here. Okay, so we're going to copy this again. But this time around, we want to find about activation's energy. Right? So activation's energy means that our focus now is on the EA. Alright, so now first we need to substitute the value. Ln is equal to, so we have the value of K2 6.30, then to the power of -4 divided by 2.52, then to the power of -5. Okay, and then we're gonna have negative. EA is the unknown that we want to find. Our R gonna be 8.314 joule per mole per K, and our T2 is 503 and also T1 463. Do we need to change it and to some other unit? No, we can simply use it because it's already in Kelvin. So 1/503 minus 1/463. Okay, so first complete the calculations on the left hand side, and then bring all these 1/, temperature to the left hand side, then times it with 8.314, and don't forget the negative sign. And lastly, our EA gonna be 155,812. So the unit would be joule per mole. But usually the EA is written as kilojoule per mole. Then we need to make this value to become in kilo prefix. So 1, 2, 3 means in kilojoule per mole. The answer would be 155.81 kilojoule per mole. Please don't forget the units. Okay. Next, we'll do the face-to-face questions. The learning objective is still the same as in previous questions, to determine the rate constants and also activation's energy using Arrhenius equations, but this time around we're gonna use graph to find the value. So given to you rate constants for the compositions of hydrogen iodide at different temperatures as below. So you're given more than 2 temperature. So means whenever you are given a set of data, then you need to do the graph. Okay, determine the activation's energy. So we want to find the activation's energy for the decompositions of hydrogen iodide graphically from the above data. And also given to you the gas constants 8.314 J per K per mole. So now we know that the Arrhenius equations is K is equal to A exponent negative EA over RT. But then when we want to change it to graph, then we need to make the y-axis and x-axis visible. So we are going to apply ln on both sides. giving you a formula of ln k is equal to ln A minus EA over R 1 over T. Based on the y is equal to mx plus c conversions, we're going to identify who's going to be your y-axis, who's going to be your x-axis. So given to you information regarding k and also t, means that only these two variables will become the y and x. So ln k will become the y, 1 over t will become the x. But in here, you haven't got any value of ln k or 1 over t. Means you need to make a new table consists of values for ln k and also values for 1 over t. So let's do that together. As for ln k, once you change it to ln k, then there will be no units for it. So we're gonna have ln k with value of negative 19.4, negative 11.9, negative 6.77, and negative 2.56. While for temperature, which is 1 over T in per Kelvin, the value will be to the 10 power of negative 3. So I'm going to put the 10 power of negative 3 here with the unit of per K. So the value will be 2 and 1.67, then 1.43, and lastly 1.25. By using these values, we're going to plot a graph for this. So we're going to plot a graph here, and the graph will be like this, where we have y-axis of ln k range from 0 to negative 20, and then as for 1 over temperature, we're going to have range from 1.1 to 2. It is not necessary for you to start from 0 because the questions keen for activation's energy. So activation's energy rely on the slope of the graph, so we have to focus on the gradient of the graph. Now let's plot. For the first point, we have negative 19.4 and 2. So the value would be around here and 2 here. And then we have negative 11.9 and 1.67. Then we have 6.77 and 1.43. And lastly, we have 2.56 and 1.25. If we take a ruler, then we're going to get a straight line here. Alright, so this is our straight line. So most of the point is on the line. Then, in order for you to find the gradient, we need to make a triangle. So since this point is on the line, from the first to the fourth point, let's say we change the color. And then as for the x-axis, so we'll take the point at, we'll take the first and fourth point to find the gradients. So if we calculate the gradient, the calculations will be like this. M is equal to, so we have negative 19.4 minus negative 2.56 divided by 2 minus 1.25 10 to the power of negative 3. So we'll get negative 16 84 divided by 7.5 10 to the power of negative 4. Lastly, your M will be negative 2.24 10 to the power of 4. But this is not our final answer. We still need to take this value and relate it to the negative EA over R. So, negative 2.24 10 to the power of 4 equal to negative. We want to find our EA, and we already know our R value, which is 8.314 J per K per mole. So now we need to calculate this value, cancel out the negative sign on both sides, and then you will get EA of 186.233 J per mole. Since EA is usually in kilojoule per mole, then we're going to change it to 186.23 kilojoule per mole. Alright, so that's all for chapter 1.1. So that's all for week 2 our 3 tutorial. So we have finished all the tutorial for chapter 1. So we're going to do some revisions next week. So please revise on this. If you got any questions, do not hesitate to ask me. So thank you everyone. Assalamualaikum.